What's up, guys? It's been a while since I posted anything on YouTube. I'm running out of car projects for now, doing some electronic stuff. So, working on a automation project with a 40 systems display and a $6 Amazon relay board. So I had to build a printed circuit board with a microcontroller on it, which allows me to communicate to the relay board and also the display and pass data back and forth. So I'm going to show you what that looks like. All right, so real quick, some of the hardware we got here. 40 systems display. Since I have 4 relays, I made 4 sets of arrows off and on. It shows this test mode. So the hardware, I have this ribbon cable, goes to this pretty much a breakout board. Wiring goes around, connects to this RJ45. RJ45 is really nice, just an RJ45 breakout board. Another Amazon part. It was like $3 or $4 for a pack of 4 unmounted housing and breakout card. So that goes to this 30-foot patch cable and then plugs into this board I made here, made a couple weeks ago. So this header here has 8 inputs, but we're going to use 7 for analog ins, and this one down here on the end is a PWM out. So you can drive a PWM, something like a solid state relay or something like that. So if I remove this ribbon cable, which is terrible because I'm only using 6 out of the like 50 pins on there, but here's the basis of this. We have a AC to DC converter. It takes 110 AC, turns into 5-volt DC. And then I have a Picaxe 20x2 microcontroller. Has something like 8 analog ins, a couple hardware interrupts that you can program. You can do some counting with that, which I might enable that. So I use 2 of the pins here. These 2 on the end actually go to the hardware interrupt input pins here. So I could set that up in programming where if you needed to count revolutions of a shaft or something, you'd be able to see that. So right now I just have 10K pull-ups, 5-volt pull-up here, and then a 1K resistor, and then I have this little array here for capacitors if I wanted to filter the input a little bit. So then you see 5 2N2222 alphas, just like a 1 amp transistor. Those drive the optocoupler on this relay board. So here you have a ground in 1, 2, 3, and 4 and a VCC, so 5-volt in, activates the optocoupler and drives the field coil on the relays. So what you're doing is you're creating a ground, which is what the transistors do. They create a ground on 1 through 4 to complete the circuit on the optocoupler to activate its internal switch to turn on the relay. So yeah, it's pretty neat. So I can use test mode and I can turn on and off each relay independently, along with read the 7 analog channels and see the state that the relays are in. So let me show you that. Alright, so this out from the laptop. Okay, so there's a small delay between when you hit the blue button, the blue arrow, for on and for off, because what happens is the display has an output request that it sends over the cable to the microcontroller here, and at the same time, it only does it at once a second, and at the same time it's sending the command to set the state of the relays. So for instance, you'll be able to hear it. So if we hit 1, 2, 3, and 4, you can see the relays, all 4 relays are set on. So then if we wanted to turn them off, right, a little bit of a delay. I had it working before it was instant, but I think I was getting some overlap on the serial commands. So we just go ahead and tie them all into one command. So now if we hit this bottom right corner, you can see the analog to digital inputs. So channel 1, 2, 3, 4, 5, 6, 7, and then the state of the relays. So 10 would be 2 plus 8. All right, so showing a 10 which is going to be 2 plus, so probably this one, that'd be 4, that'd be 8, so it should be this one and this one on. So if I turn on this one and this one, should give us a 30. There it goes. Give us a 30, which would be what, 2 plus 4 plus 8 plus 16 is 30. And I'm still trying to sort out why it doesn't quite come in correctly when the page loads. I'm not really sure what the deal is there, but figure it out. So there you have it. And then the analog inputs are, so this one I have over here is wraps around to here. So that would be what, 1, 2, 3, fourth one in. So we have a value of 482, which is going to be about right, because that one's getting the heat off of the laptop. Is going to change the resistance with the pull-up resistor and all that. It's going to give us a different value there. This other, the fifth one, which is this one here, or sixth one, which is that one there, is the one that's just sitting on the floor down here. So it's going to be whatever the temperature of the floor is. So I'll later convert the analog to digital value to a human value in temperature F or C, and be able to display that on another page.